Hi dear students, welcome back. Dear students, in this video we are going to discuss about the position time graphs and how many types of graphs are there for different situations, how the graphs are there, and we are going to discuss some of the example problems based on the graphs. That's why you have to watch the video up to end without any skip. Okay, let's go to the topic. Position time graph, velocity time graph. So we have different kind of graphs are there. In this video we can discuss about the only position time graph. Dear students, if the position of the particle is changes with respect to time, then maybe its velocity, displacement, acceleration may be changes. Those should be identified with the help of the graphs. Okay, so for example here one graph it is there. To understand this, simply here we are taking the position on y-axis and the time is on x-axis, and we are showing that the position of the particle should be like this. What it is say same, that is I am going to draw here. At this point A, I am saying now it is A, B, whatever may be. Here for the position time is t1 and its displacement is here now y1. Clear? Final position B, for at that time the time should be taken as t2 and its displacement should be taken as y2. What is y2? Clear? And in this case here change in displacement, what it is, simply here y2 minus y1, and change in time. So now here change in time, that should be taken as t2 minus t1. So what we know, change in velocity, change in displacement for time, what do you use? Velocity. So here we will write velocity is equals to delta y by delta t. Here what is delta y? y2 minus y1, and delta t is t2 minus t1. That's why here velocity should be given by the formula here y2 minus y1 by t2 minus t1, like that. So now if you can take, this is the horizontal and that will make some angle here theta. Clear? So I am going to say A, B, it is C now. From that graph what you can write, tan theta is equals to what you can write, tan theta is equals to here BC by AC, opposite side by adjacent side. Tan theta is equals to BC by AC. And now you can observe here from this graph or diagram. So I am going to say BC is equals to here now D. BC is equals to AD and BD also equals to AC. That's why here I am going to write tan theta is equals to here, instead of BC what we can write, AD by AC. So if you can take this one, in this case what write, tan theta is equals to here BC by again AD, same thing. Here what is AD here? Nothing but displacement y2 minus y1, and what is AC? T2 minus t1. That's why here what is tan theta is equals to y2 minus y1 by t2 minus t1. So already we have taken, this is what equation number 1, V is equals to y2 minus y1 by t2 minus t1. And now here tan theta is equals to y2 minus y1 by t2 minus t1. This is the equation number 2 now. From 1 and 2 what we can write, simply you can write V is equals to tan theta. V is equals to what? Tan theta. Nothing but what you have to say, the slope, the tangent of slope of the given this particular position of the particle should give the velocity. The slope of that particular curve or anything whatever may be, that should be here equals to the velocity. Tangent of the angle should be given what is velocity. So by using this basic principle, we have to understand the different situations for different graphs. See some various position time graphs and their interpretation. So we have some graphs are there. Look here. If we can plot the graph between position and time for different situations, here the first situation is there. Here what you understand here, this line is parallel to the time x-axis, it is parallel to the x-axis. So here what you have to say, already we discussed what it is. Y is equals to some here y2 minus y1 by t2 minus t1, that is what you have to write, some velocity what we discussed just now. Here in this case we can take, here there is no change in position, there is no change in position, it is a horizontal line and that should be parallel to the time axis. That's why here what you have to say, y2 minus y1 means here it is same, y minus y by here t2 minus t1. For example, I am going to say here t1 is 0 and here some t2 is some, I am going to say 20 and it is some here 30. So at the time t is equals to 0 seconds, its position is 30 and time t is equals to here, I am going to say 20 seconds, then also it is 30. That's what you have read here, 30 minus 30 by here what it is, 20 minus 0, 20 minus 0. So 0 by anything is 0. That's why here when the given graph, in that given graph if the line is parallel to the x-axis, then what you have to say, the body should be or the particle should be at rest, particle should be at rest and velocity is equals to 0. Why? Because here slope also 0, slope also 0. Already we discussed tan theta is equals to v. Here it is parallel to the x-axis, that's why here angle is 0. When angle is 0, velocity also 0. That means what? The particle is at rest position. So this is the interpretation regarding the first one. Here the particle is at rest, velocity is 0 and slope also 0. And now here second graph. In this graph line is parallel to the x-axis. Now this line is parallel to the y-axis, parallel to the y-axis. So it means that what? Here the position of the particle is changes but the time is constant, time is constant. So again we can take same formula, v is equals to y2 minus y1 by t2 minus t1. Here t1 is equals to t and t2 also t. That means what we here y2 minus y1 by means here y2 minus y1 by t2 minus t1, t minus t. That means what? y2 minus y1 by 0. Anything by 0 means what? Infinity, infinity. Here the slope is nothing but here theta is equals to 90 degrees and here velocity is what? Infinity. Velocity is what? Infinity meter per second. But practically it is not possible, not possible, because with respect to time only the position will be changes but here time is constant. Got it, children? When the given graph the line is parallel to the y-axis, what you have to say? Velocity is infinity. Why? Because there is no change in time. What we know, velocity is equals to y2 minus y1 by t2 minus t1. So that means what? Here the maybe here this is the y1 value and this is y2 value. There is some change in position but there is no change in time. Then obviously what you can take, same time means here it is 0 will get, that velocity is what? Infinity. But practically it is not possible, children, you have to understand that. And now third graph it is there. Here what you are finding, here the line is passing through the origin, passing from the origin, it is a straight line. So it means that it is quite similar to the y is proportional to x. So some y is equals to k into x, y is equals to k into x, that is the equation here. So in this case what you can understand here, there is some proportionality, there is some proportionality between the position and time, position and time. So for example here if you, this is the angle and if you can take again the slope will be same, the slope is everywhere same. It means that here when slope is same, what you have to say? Velocity is constant. What is? Velocity is constant. When velocity is constant, acceleration is 0. Clear? In this case, The slope of the line, the slope of the given curve or line, whatever may be it is given that the graph, that should be here have a constant value. That means here if you can take, for example, I am going to say this is 0 now, time 0, and for this one I am saying it is A and this is the B. So here B, C, D will take. Here for the A, time is 5, B, time is 10, and it is 15, and it is 20. Here A is 10, B is 20, and C is 30, and D is 40, like that. So if you can go for O to A, then V is equals to what, right? Y2 minus Y1 by T2 minus T1. So here it is 0 at A. What is this is what? 10, and initial position what? 0. So 10 minus 0, and what is here? T2 minus T1, 0 and 5. So 5 minus 0, that is what? 10 by 5, that is what? 2 meter per second. In the same manner, if you can go for A to B, so this one, at A time is what? 5 seconds. At a B time is what? What is 10 seconds. And similarly here displacement is what? Y1 is here 10, and Yd is what? Here 20. Then again you substitute, V is equals to Y2 minus Y1 by T2 minus T1. So 20 minus 10 by 10 minus 5. Again what you get? 10 by 5 you get. That is what? 2 meter per second. 2 meter per second. So you can take any interval, then velocity is constant. When velocity is constant, acceleration is 0. Why? Because acceleration is what? Change in velocity by change in velocity for time. At every time what you get velocity? 5 minus 5 by time whatever may be. That is what? 0. That's why when the line is coming from the origin and it seems to be a stairs, the line is coming from the origin and that should be a straight line, then what you have to say? The velocity is constant but acceleration is 0, and every time we have the same tangent of angle, slope is same. Okay, some other graphs are there here. Again on y-axis we have position is there, time, position, time, again position and time. So you have to remember, children, in this case the line is moving towards position vector, towards the position axis. So in this case we can observe that here theta is increase, theta is going to be increase. That means what? Slope is increase. Then obviously velocity also increases. Then A is positive, acceleration is positive. So here you may take here angles, the angle is going to be increase. Clear? So here these are the angles. But in this case opposite to this one, here it is moving away from the position axis. In this case theta is going to be decrease. Then obviously velocity also going to be decreases. Then acceleration is negative. Acceleration is negative. In this case theta is gradually increase, then velocity also increase, acceleration is going to be taken as positive. But in this case the line is moves away from the axis, position axis, then the theta is decrease, velocity also decrease, acceleration is taken as negative. And next one, this one children here. So it is the, as it comes like this. You can take here, this is the angle, that angle is greater than 90 degrees. Angle is greater than 90 degrees. When angle is greater than 90 degrees, then slope is negative, then velocity also negative. Velocity also negative. Clear? So in this case maybe velocity is constant. Velocity is constant, but it is negative. It is negative. So here very simple to understand here. For example, at this position the values I am going to take 40 and it is now here some 20, it is water maybe. So it is 0. So obviously here what, right? Velocity is equals to y2 minus y1 by t2 minus t1. So this is the position A, starting position, this is the starting final position B. At the position A what you have? Yes, 40 is there. At B what you have? 0 minus 40 by 20 minus 0, that is what, minus 40 by 20, it is obviously what, minus 2 meter per second. That's why in this case velocity is, maybe it is constant but its value is negative. And to remember that, simply when the slope is more than 90 degrees, the velocity is negative. Let's see, some other graphs are there. Here again we have to take the same thing here, position on y-axis, time is on x-axis, position, time, again position and time. So look here, in this graph, in the first one, the velocity is changes per particular straight line to straight line. Here O to A, one velocity will be there, again A to B, one thing will be there, and B to C also different, and C to D also different. So when the position of the particle should be changes in this aspect, the velocity is going to be changes. For example, here I am going to say 5, 10, 15 and it is 20, and in this case here 10, 15, 20 we are taking like that. So from 0 to A or OA, for OA velocity, how we can write, V is equals to here y2 minus y1 by t2 minus t1. O to A, at the position of A, time is 5, as here is 10, displacement is 10, then what at here, 10 minus 0 by 5 minus 0, 10 by 5, that is what, 2 meter per second. And you can take some A to B, at the position of B the time is 10 seconds, at the position of A time is 5, here it is now 15. Clear? So that's why here what you have to take, for AB, for the line AB in that graph, what we write, V2 is equals to here, simply I am going to write here what is 15 minus 10, 15 minus 10 by 10 minus 5, that is what, 5 by 5, that is what, 1 meter per second. Clear? And next we can go for B to C. So for BC what you have to say, here displacement is constant, that's here 15 minus 15 by here 15 minus 10, that is what, here 0 meter per second. B to C, that's in rest position we can take. And again C to D also it is, we are taking what is C D. For D, y2 is 0 and it is 15 by, again what is here, C D, time 20 here, and it is, yes, 20 minus 15, so it is negative velocity. That's why here from line to line, from O to A one velocity is there, A to B another is there, B to C one more is there, C to D also is there. For particular time of interval, velocity is going to be changes. So that should be, you can easily understand from that one. And next in the second graph, for example here it is, I am taking, this is the position here, 0, 5, 10, 20, 25 seconds. At a position of here 5 seconds, the particle is at two positions, A, B. At A it is there and B it is there. For the same time of instant, that should be at two positions, but it is not possible. Clear? And similarly we can, by using the same formulas here, in the previous graphs also we discussed. Here in this graph here, for example, I am saying A to B. A to B is velocity is going to be decrease, B to C velocity is going to be increase. So these are the graphs you have to remember at least one question to solve so many problems. Okay, let's see some problem. Let's see one problem on position time graph. The problem should be like this: displacement time graph of a particle moving in a straight line as shown in figure. State whether the motion is accelerated or not. Describe the motion in detail. Given S naught is equals to 20 meters and T naught is equals to 4 seconds. So he was given one graph for us. We have to explain this body is accelerated or not and how, in which direction it is moving. That is the question here. Very simple to understand here. Time is taken along the x-axis and displacement is taken along the y-axis. When the time t is equals to 0, the position of the particle is what? S minus S naught. So we have to remember, when time t is equals to 0 seconds, the position of particle is where? Minus S naught. And what was given S naught? 20 meters. 20 meters. When the time is 0, this is what? Minus 20 meters. After that, when the time t is equals to t naught, when time t naught is what is given? 4 seconds. When it is 4 seconds, the displacement is what here? And this is what? 0. Displacement is what? 0. So S is equals to 0. After that, again time increases and displacement also increases. So to understand that, simply here we have to draw this one. What was given? When S naught is, when t is equals to 0, what is? 20 meters, and that is what? Minus 20 meters. When time t is equals to 4 seconds, what is? 0 meters. That means that what? We have to show like this. When t is equals to 0, what it is? Minus 20 meters. When t is equals to 4 seconds, the displacement is 0. So here S is minus 20, here S is 0. That means what? It is moving towards the positive x-axis. The particle is moving along the positive x-axis. So, and you have to understand with what velocity that is moving, you have to identify that. So for that, simply you can write the velocity formula. What is? V is equals to, here I am going to write x2 minus x1 by t2 minus t1. Here what is x2? x2 is 0. 0 minus x1 is what? Minus 20. Minus 20 by t2 minus t1. 4 minus 0. That is what? Minus of minus plus. 20 by 4. That is what? 5 meter per second. So it is moving with the constant velocity of 5 meter per second. The particle is moving towards the positive x-axis with what? With constant velocity. That is what? 5 meter per second. When it is having some constant velocity, obviously the acceleration is 0. See the next problem. From the displacement time graph, find out the velocity of a moving body. From the displacement time graph, find out the velocity of a moving body. Options are given: 1 by root 3 meter per second, 3 meter per second, root 3 meter per second, 1 by 3 meter per second. So you have given some graph already. So here the how much angle is mentioned? 30 degrees. So displacement time graph. So already starting of the video only we discussed what it is. When we considered displacement is on y-axis and time should be on x-axis, then we are showing that it is the V is equals to tan theta. V is equals to tan theta. That is what? y2 minus y1 by t2 minus t1 we discussed. But in this one graph he was given, the line makes some angle with the displacement, that is 30 degrees he was given. This is a 30 degrees he was given. Clear? So but what you have to understand, we have to take this one only. V is equals to tan theta is applicable only when the line can make some angle with the time. So that's why here according to that one, so this is total is 90 degrees. 90 degrees. The line should make some angle 30 degrees with the displacement. Then how much with the time? That is 60 degrees. 90 minus 30. That is what? 60 degrees. That means what here? We will take like this now. Time, displacement, and this is should be like this. This is the right diagram. So obviously the formula is here. V is equals to tan theta and V is equals to tan 60. Tan 60 is what? Root 3. So root 3 meter per second. So that's why among the 4 options, third option is the correct one. Okay, dear students, I will upload the one more video for the problems which are given on the position time graph. To write the online examinations, just you have to download the my app N. Kumar Basics of Physics from the Google Play Store. And to get all the notifications from my channel, you have to subscribe my channel and press the bell icon too. Okay, thank you for watching.